Hello.
Good day.
Counting moles.
And formulas and equations.
Yeah, so this is what those equations really mean.
What? Yeah, exactly.
Oh, there we go. Sorry.
Oops.
Watch it again. It takes some time.
Yeah, to speed that one up next time.
Yeah.
I'll be able to count moles of atoms in chemical formula and moles of molecules in chemical equations. Let's do it.
Let's do it.
Let's do it. The subscripts. I said this in the definition, so I'm going to take this one.
All right.
This is there is. What is this? The subscripts in a chemical formula mean that there is that many of the element that directly precedes a subscript. I need an example.
All right.
There we go. C6H12O6.
So the 6 means
there's 6 carbons.
Fact. See, it's in front of it. It's after the carbon.
And the 12 means that there's 12 hydrogens. Okay. And the O means there's 6 O's. Okay. And specifically, there's 6 moles of carbon, there's 12 moles of hydrogen, and 6 moles of oxygen
in 1 mole of that that molecule. Mm-hmm. Right. So parentheses in a chemical formula means that there's a polyatomic ion present that stays together in these little packets. It don't break up. If you remember in the POGL from last unit, when you got to the water, it was a good example in the sim that didn't break up. It doesn't dissociate. Right. So this OH is going to stay together. So what that means is OH, polyatomic ion called hydroxide.
Bingo.
How many of them is there?
1.
In that particular equation, 1.
Uno. Parentheses with subscripts means you double or triple whatever that polyatomic ion is.
Facts.
And you distribute mathematically to get it. So mg's, there's no subscript after mg, so we assume it's 1.
Facts. 1
mole of mg in a mole of this compound. Now the ends, we're going to distribute the 2 back in. So there's actually 2 nitrogen moles of nitrogen in this compound. And the oxygen, we're going to distribute the 2 in, and we get it 6. So in 1 mole of magnesium nitrate, there are 1 mole of magnesium, 2 moles of nitrogen, and 6 moles of oxygen. That's how you count them.
Yes. And we need to be able to count them, or we can't get to the next piece. This is the first step. You got to get it right every time. So some examples. Let's do, can you circle 1 for each that we're going to do? You do need to do all of them. But we're going to show you how simple this is. So we're going to write a BA out and CL out, and we just need to count how many of them there is of each. And I see no subscript after BA, so it is a 1. And I see a subscript after CL, and that is a 2. So there's 2 moles of chlorine for every 1 mole of barium. Next one, how many nitrogens? 2. And oxygens, we learned how to name this last unit. Dinitrogen pentoxide.
Boom.
Wow. Next one, now we get some subscripts, so this one's a little crazy. We are going to separate the O's and the H's out just so you can see how many of them there are. Okay, there is nothing behind the BE, so we're going to say 1. There is 2 moles of OH, which is hydroxide, and that means when I distribute, because there's 1 O and 1 H, there's 2 of each. Okay, 2 moles of oxygen, 2 moles of hydrogen. We are not going to walk you through all the rest of these. Guess what? You need to follow what we just did and finish all of those out.
Yep.
Okay?
Because there's other examples we want to do.
Yeah, we got to make sure we got enough time to make sure you get through everything.
So mole coefficients are written in front of compound formulas and mean something else. It means the number of moles of that compound. We just showed you how many moles of atoms were within a compound, but you could double or triple the number of compounds itself. And so this could mean the number of atoms or molecules in that compound.
Right.
It's never going to mean grams, though.
Never.
Never.
Because we need to make sure that it's never straight up grams. We can't relate grams that way. We have to go through a special avenue to get there. Okay? Chemical equations are a simplified recipe, right? 2 moles of hydrogen react with 1 mole of oxygen. This is right from this box we're reading. So it says 2 moles of hydrogen, boom, react with 1 mole of oxygen. And there's some practice on this. You need to be able to write these words out from this chemical reaction. React to form, or to produce. That's the arrow.
Mm-hmm.
And then it produces 2 moles of H2O, or 2 moles of water. You can name that however you want. But notice the moles. 2 to 1 react to get 2.
Yep.
And they don't necessarily add up.
Nope.
Right? I got 3 moles on the reactant side. I got 2 moles on the product side. Those numbers don't have to jive. What has to jive is the number of atoms. We'll get to that in a later video.
With bonding. With balancing, sorry. Yep. Okay. So example, counting moles of atoms and compounds in the chemical equation. So let's do it. Yeah, go for it, Milks.
Okay.
So he's got 2 moles of H2. So H2 comes in packages of 2. So he's got 2 moles of H2. So he's counting, he actually has 4 H's, 4 moles of hydrogen. Now he's got 1 mole of O2, and O comes in packages of 2. So 2 times 1 is 2 moles of O2. Mm-hmm. Now he's got 2. Yeah,
2 moles
you
of
messed
O.
that one up. 2 moles of O. Mm-hmm.
Yep.
Now he's got 2 moles of H2O, and H2O comes in packages like this. H2O, he's just going to draw H2O out twice so you can see it. H2O, draw it out twice, yep. And now he's going to count and see, well, he's got 4 hydrogens altogether and 2 oxygens altogether. So using the distributing rules and doing a little drawing, you can figure out how many moles of atoms of each type are in the chemical equation.
You know what's sad? Well, I was just so excited to draw on the board, and I bet it's all animated out.
Maybe.
Let's see if I got it right.
Oh, let's see if you got it. Mr. Milk is checking his work. 4 total moles of H atoms because 2 times 2 is 4. Distributed
Thanks.
property. 2 total moles of oxygen because 2 times 1 is 2.
Thanks.
And 2 times 2, 4 moles of hydrogen. And then 2 times 1. That 1 is not written, but it's implied. 2 moles of oxygen.
I got it
You
right.
did do it right.
Okay, good. So now let's see if we can talk our way through this one, because this one isn't necessarily animated.
Okay, I see the simplest, easiest one. There's 4 moles of iron, 4 Fe's.
There we go. And I see 3 in front of oxygen, but I have to relate that to the 2.
Distributed
right,
3
so
times 2,
there's
6 moles of oxygen.
Joe. So make sure you write that, even though we're not saying it.
React to produce
2 moles of this iron oxide.
Yep.
And I believe it's iron 3 oxide, if I remember correctly.
Yep.
And so 2 distribute to the 2 is 4. There's going to be 4 iron atoms and 6 oxygen.
And that's all. So in your practice for this one, it's all about writing out the name of the equation. So you'll see a chemical equation, and I want you to write, 4 moles Fe combined
Yes.
with 3 moles O2 to react to produce 2 moles Fe2O3.
Yep.
Okay.
And then there's some practice on counting, I think, too. We're just straight counting up atoms.
Mhm.
We got to get this piece right. It seems like it's not that important. Watch next video how important this comes in, because one mistake in the counting will transcend all the way through all the other steps we're going to do.
We got
This
a
unit
minute to
builds on
make
itself.
sure we can count our atoms. Okay, so the first practice set, page 10, you're counting atoms in compounds.
Literally.
And then towards the end, you get some subscripts, so remember to distribute back. Simple stuff.
Yes.
The second practice page, page 11, is
writing out
converting
these
an
chemical
equation into the word version.
Yes.
1 mole of barium carbonate combined with 1 mole barium oxide and 1 mole CO2. Okay?
All review of stuff we've already learned.
Absolutely.
Except adding in this moles piece.
I do want to see you use the actual names of these
I would
compounds
like
that you learned. I don't want to see 1 mole BaCO3. No, you know the naming rules now from
Yes.
chemical bonding. Use them. If you don't
Yes.
use them, you will lose them. And that is a surefire way to lose points on the Regents exam.
Yeah, you definitely need to know your stuff.
So 2 pages, very much like what we just showed you.
Yeah, we'll probably work out 1 or 2 in class for you, but we're not working all these out in class. You're
Nope.
going to have to, earn your stamp, check your work.
Next video, we're going to actually use the counting atoms to figure out how much a mole of each compound will weigh on a scale.
And we need to be able to count them accurately. So, with that being said,
Deuces.
find a button.
Find the button and turn it off. I gotta turn it off. I gotta turn it off. I need to turn it off.